Hello all, welcome to Code Hub. Today let us solve the Lead Code's daily challenge. The problem is most stones removed with same row or column. On a 2D plane, we place n stones at some integer coordinate points. Each coordinate point may have at most one stone. A stone can be removed if it shares either the same row or same column. Note this point, either it can share same row or same column as another stone that has not been removed. So given an array of stones of length n, the stones of I is equal to x comma xi yi represents the location of the ith stone. Return the largest possible number of stones that can be removed. So these are the given stones, and uh, let us see an arrangement of stones that are removed. As you can see that this 0 comma 0 and this 1 comma 1 is can be removed, can be used to remove one stone. We can remove 0 comma 0 or 0 comma 1. So this removes one stone. Then 1 comma 0, 1 comma 0 is also mapped with 0 comma 0. So we can also map with 0 comma 1 comma 0 to 0 comma 0, as it shares the same column number, as 0 comma 0 is sharing the same column number as 1 comma 0. Then 1 comma 2, in 1 comma 2, as you can see that 1 comma 2 can be mapped with this 1 comma 0, as it shares same row number. So even 1 comma 2 can be connected here. And 2 comma 1, as you can see that 2 comma 1 is can be connected with this 0 comma 1, so as it can be removed from 0 comma 1. So as it shares same column number, so 2 comma 1. Considering 2 comma 2, as you can see this 2 comma 2 shares the same row number with 2 comma 1, and 2 comma 2 shares same column number with this 1 comma 2. So obviously we can remove this 2 comma 2 from 2 comma 2 stone. So you can see that I have just connected based on their rows and columns if it is equal to either of the stone that are connected previously. So by doing this, what I do is I have formed one component. So if there is one component, I can remove the total number of stones that are present. Here is considering it as n, considering the total number of stones to be n, to be which is 1 2 3 4 5 6. So there are 6 stones and I have only one component, so I can just minus the number of stones, the minus the component number with the number of stones, so which is equals to 5. So that is our required answer. Consider we have an extra 2 points, like let's say 3 comma 4, and another stone which is at some coordinate like 5 comma 4. As you can see that this 3 comma 4 and 5 comma 4 shares same column number, so 3 comma 4 will be mapped with this 5 comma 4, and this shares the same column number, and there are total considering there are total 8 coordinate points, 8 stones, right? There are 8 stones in this array. So there are two components formed. So from this one point I can remove these many number of stones, and from this one point I can remove these many number of stones. So obviously I'm going to remove this 0 comma 0 and 3 comma 4. This is nothing but representing the number of components. So total stones are 8 and the total number of components is 2. So 8 minus 2, which is nothing but 6. So the answer will be 6. You can remove this one stone and you can remove this 5 stones. So obviously the answer is 6 here. So the formula for finding this is nothing but 8, the total number of stones, minus the number of components. So this is what the formula for finding the number of stones removed. So how can we do this? So let us try to visualize this. I will take in to a paint and let us see. Let us represent here. So can we paste here? Just a minute. So consider these are the number of stones. These are the stones that are given in our array, in our input, which is there are 8 stones. So if they are going, if we cannot, obviously we cannot relate with the x and y. So what we can do is we can consider this as ij. So considering it as ij, it is 0 index, 1 index, sorry, it is at 1 index, it is at second index, it is at third, it is at third, and it is 4, and so on. So 4, 5, 6, 7. So what I can do is I can run a for loop, two for loop. If there is a row number equal to a column number, I can just form a graph representing that they are connected. So the what I can say is this 0 comma 0 is connecting with 1 0 comma 1. So obviously I can just have a have a edge between them, 0 and 1. And even the 0 comma 0 is connected with this 2, so I can have an edge between them, 0 comma 2. And 0 comma 0 is not connected with 1 comma 2 and either of that, so why it is having an edge between 1 and 2 only, the stones with the index 1 and 2. And now for 0 comma 1 there is an already an edge between 0 comma 0, and let us try to map with other stones. 0 comma 1 maps with the stone 4, which is at the index 4. So we can have an edge between 1 and 4. And then 0 comma 1 does not have any edge between them other than 1 2 and 1. So 1 comma 0 1 comma 0 there is an equal row number with the in stone 3, so we can just have an edge between them. And 1 comma 0, that's it. And then let us go for 1 comma 2. 1 comma 2 shares an edge between the index 5, this is 5, and this is 6, and this is 7. So 2 comma 1, sorry, 1 comma 2 shares an edge between 5, so let us connect this like this 5. And then 1 comma 2 is that's it for 1 comma 2. And let us go for 2 comma 1. For 2 comma 1 there is an edge between 5, so we can have an edge between 2 comma 1 and 2 comma 2. And then we can go for 2 comma 2, there is no edge after that, so let us go for 3 comma 4. As you can see that 3 comma 4 is having an same column number with 5 comma 4. So let us map with 6 and 7. So as you can see that there are two graphs here, which is nothing but now we can just find the number of components, and after finding the number of components we can just say the total number of stones minus the number of components. So to find the number of components we can just do a DFS traversal. After doing a DFS traversal we can say we can use the number of components to be decrement from the total number of stones. So it is simple DFS problem. Let us try to code it soon, as soon as possible. Hope you visualized the problem how I'm doing it. So now let us try to code it. So first we need a graph, so we can say it as vector of int graph of size n. N is nothing but the number of stones. N is equals to stones dot size. Now what we have to do is we have to create a graph. So how can we create the graph? So first I have to run a loop for each and every index. So obviously it is going to be an 2 for loop to have a path between every edges. So 0 and I less than n and I plus plus, and I can just have j equals to I plus 1, j less than n, and j plus plus. And I want to check whether it shares an edge. Share, I can say it as can is share same row or call. this function is going to say whether this stones of I and stones of J is sharing a row or column. So that I will declare later. So I will just pass stones of I and stones of J. If this is going to share, then what I can do is I can just connect the I and J as an undirected graph. So graph of I dot pushback, sorry, dot pushback of J, and similarly I can just have an alternative edge between J and I. So now I have created the graph. Once I have created the graph, I'm just want to find the number of components. So total components, I can say it as total components equals to 0 initially, and finally at the end of the day I'm going to return n minus the total number of components. So this is my formula to find the number of stones removed. So to find the total components, I want to do a DFS traversal. So before doing a DFS traversal, what we have to do is to do a DFS, we need an visited array first. So we can just have a vector bool visitor of size n, and initially it can be initialized with false, and we can just run a for loop from int I equal to 0, I less than n, I plus plus. If this node is not visited, if it is not visited of I, then I can just visit. So before visiting, I will just increment my total number of components. So once I increment the total number of components, I'm going to do a DFS on this graph from this node I, and I'm going to pass this visitor as well. So what does this DFS will do from this node I is, if I'm calling this DFS from 0, I will visit all the nodes that are connected with this 0 by doing a DFS traversal. And if I call with 7, I will visit all this connected components, connected edges with which are connected with this 7. So that is what the DFS does. And now let us try to write the DFS function. So before writing the DFS function, let us have this is share the same row or column, which is going to take a vector int stone A and vector int ampersand stone B. How can I say this is sharing between them? If my stone A of 0 is equal to stone B of 0, or my stone A of 1, whether it is sharing a same row or it is sharing a same column, I can just say like this, and this is going to return me true or false. So once I have done this, now let us write the function for DFS. We have void DFS, which is going to take a vector of int graph, and it is an array, and I need a node int node, and then I need a vector of bool visitor. So what I can say is, if once I come inside this loop, I will just visit the node, visit of node equal to true, and now I want to go for all its adjacent node. So auto edge of graph of node, if it is not visited alone, if it is not of visited of node, I will do a DFS for that adjacent node, graph adjacent and visited. So that's it. Now we have done the DFS, and we have connected the number of components, and we have just returned the total number of stones minus the number of components. So let us try to run our code. Okay, it gets some wrong answer. Now let us try to debug what is happening here. Sorry, there is a typo. It is if the adjacent node is not visited, I want to do a DFS. I have checked it as visited of node. Okay, it gets accepted. Now let us try to run the example test cases as well. Superb, it gets accepted. Let's submit the code. Superb, it gets submitted. Hope you like the solution, but what will be the time complexity for the solution? The time complexity will be an order of n square. We are running two loops here, and this DFS is going to be an order of v plus e, let's say, and the total time complexity for this DFS is nothing but the time complexity here will be an order of n square plus an order of n plus b, let's say, as like this. And what will be the space complexity for this DFS solution? Order of n plus b. So this is what we can say for the time and space, and this is a DFS approach. Let me also teach you how we can do an union find on this problem. As you can see that there are components involved. This is a graph problem. So to find a to do as a union find problem, as you can see that the 0 is also connected with 2 3 5 and 1 4. If I'm able to do a union find on this graph, if easily we can just find we can reduce the time complexity drastically. Instead of taking this order of n plus b, using a union find, what we can do is we can just reduce the time complexity to order of n square plus alpha of e. It is drastically much better than yeah, the DFS solution. So this is an union find approach. Let us try to do this as well. So to do a union find, we can just have a class. So how can we do a union find? Is nothing but before seeing this approach, you have to know basic union find. The union find will be containing two functions, find parent and union function. These methods will be useful for doing a union find. What we'll be doing is we are creating a graph here. Instead of creating a graph, we will just union both I and j. So once we have union the I and j, so and on the go we can calculate the total number of components as well, and finally we can apply the same total number of stones minus the total number of components. So that what we can do is we can just directly do the union find so that it will be more easier to understand. So this is union find class. I am going to have two things, vector of int parent array and an rank array. So I also need the total number of components, so I can just say the components. I can also have the components in this class itself. So now we can declare the class, we can declare this. Before that I will declare the constructor is nothing but union find. If I give the size, I will declare reinitialize the size parent dot resize of size n and rank dot resize of size n, and my components equals to 0 initially, and my for int I equals to 0 and less than n I plus plus. We can just say parent of I is nothing but I himself, and rank of I is equals to 1. So we have the union find constructor. Now let us declare the other functions. Int find parent, or which is going to take a node. If my u is equals to my parent of u, then we can just return u itself. Else we can just do a path compression. Parent of u is nothing but my find parent of u, and now we can just do a union or union operation between u and v. First find the find parent of u, next we can just find the parent of v. Once we have find the parent, if my u is equals to v, we can just return. Else we can say the component So initially the component is the total number of stones present. So whenever the parents are different, then what I'm going to do is I'm going to union this u and v. So the total number of components will be get reduced by 1. So components minus minus, and we are going to update the rank and the components parent array. So rank of u is lesser than or equal to my rank of v. Then I want to increment my rank of v plus equals to my rank of u, and my parent of u is my v, else my rank of u plus equals to my rank of v, and my parent of v is my u. So this is how we can do a union operation. And now we can also have the get components method. This is going to give me the total number of components in get components. So return components. So this is as simple as that. Now let us try eliminate this DFS function, and we can also eliminate this code. This is the union find approach. Instead of creating a graph, now we are just going to do a union operation here. So first we need a union find object. So union find DSU of size n, and what we can do is if it is going to share same row or same column, we are just doing a union operation. So DSU dot union of I comma j. So once we have done the union operation, we can just get the components by DSU dot get components function. Now we don't want this stuffs, and it is lot reduced. And let us now try to run our code. Yeah, sorry, this is a class, we need a semicolon over here. Superb, this also gets accepted. Let us try to run our example test case. Now let us submit the code. Superb, even this gets accepted. So hope you like the solution. Both I have also taught you the DFS solution as well as the union find solution. Union find is also pretty simpler. We have a constructor, we have a find parent. This is doing the path compression here, and this is the union operation. We are doing a union find by size, and this get components will be giving my total number of components. And initially this constructor is itself initializing the total number of components to n, and once it is sharing a same row or same column, I will just do a union operation and I will get the total number of components by this, and we can finally return the n minus the total number of components. So this is the solution for union find. The time complexity will be n square plus alpha of n, where alpha is very constant in union find. We cannot define the time complexity very accurately here, but anyways we can say it as alpha of n. It is a constant time, let's say it is proven to be constant. So hope you like the solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.